Hi everyone, in this video we'll see few more MCQs on synchronous machine. The first question is the open slots are more commonly used in the stator of a synchronous machine as options are the inductance of the winding is less, option B they permit the placement of farm wound and insulated coils giving least expensive and more satisfactory, option C both A and B, option D none of these. The answer is open slots are commonly used in the stator of a synchronous machine to reduce the reactance. First one is reduce the reactance. And the second thing is make the magnetic field distribution more sinusoidal. Next, open slots in the stator of a synchronous machine contribute to a lower inductance in the winding. Third one, lower inductance in the winding. And fourth one, allow the use of farm-wound insulated coils. So here, option C is the correct, both A and B. Next question. Large synchronous machines are constructed with armature winding on the stator because stationary armature winding. First one can be insulated satisfactorily for higher voltage. Second thing can be cooled more efficiently. Third one would lead to reduced slip ring losses. Fourth one would have no slot harmonics. Fifth one would have reduced armature reactance. From this, the correct answer is option A, option B, option C, and option D. Here, the correct answer is large synchronous machines are constructed with armature winding on the stator because stationary armature winding can be insulated for higher voltage, cooled more efficiently, and reduces slip ring losses. Next thing, it has a few more advantages. Stationary armature requires lower maintenance, and it provides greater mechanical stability. Next, stationary allows for a higher rotor speed and which increases the synchronous machine output. And it would have reduced armature reactance. The armature reactance in a synchronous machine is largely influenced by leakage flux, which does not contribute to the main magnetic flux, but instead links with only the stator winding. When the armature is placed on the stator with open slots, the leakage flux is minimized, reducing leakage reactance. So here option B is the correct one, 1, 2, 3, 5. Next question. Damper windings in a synchronous machine are options are embedded on the rotor in interpolar regions to prevent the rotor from running at synchronous speed. Option B embedded in the pole shoes to prevent the rotor from running at supersynchronous speed. Option C embedded in the pole shoes to reduce the rotor oscillations above the operating point. Option D embedded on the rotor in the interpolar regions to reduce rotor oscillations above the operating point. The answer is damper windings are located on the rotor poles of a synchronous machine. Damper winding consists of a copper or aluminum bars embedded in the pole shoes. These bars are short circuited at both ends by a ring and acting as a squirrel cage induction machine. This winding, damper winding in a synchronous machine are employed to suppress oscillations, provide stability during startup, prevent hunting, and it provide damping torque, which helps the rotor lock into the synchronous speed during synchronization. So here option C is the correct one. Embedded in the pole shoes to reduce the rotor oscillations above the operating point. Next question. In cylindrical rotor, dash portion of rotor is wound. Synchronous machine wound over 2 by third of the circumference and left unwound over the remaining 1 by third for harmonic reduction, mechanical strength, thermal management, and optimize the flux distribution. It means the portion which left unwound 1 by third portion makes rotor to distribute uniform flux. Next, these design choices enhance the machine overall performance and longevity. Next question. The aircraft alternators are designed to generate EMF of high frequency of 400 Hz in order to options are reduce the bulk, option B compensate for high speeds, option C makes the system free from external disturbances, and option D all of the above. Here the answer is A, reduce the bulk. Next question. The maximum electric current that can be supplied by an alternator depends upon options are strength of the magnetic field, Option B, number of poles. Option C, exciter current. Option D, speed of exciter. Here answer is the maximum electric current that an alternator can supply is mainly dependent on the strength of the magnetic field. The stronger the magnetic field in the alternator, the greater the potential output current up to the machine design limits. While exciter current and speed of the exciter influence the strength of the magnetic field, it is ultimately the strength of the magnetic field that directly impacts the maximum current that alternator can supply. Here answer is option A, strength of the magnetic field. Question: in turbo alternators, smooth cylindrical rotors have very long axial length because it. Options are reduces friction and windage loss. Option B, reduces centrifugal force. Option C, number of conductors being less and they have to be necessarily long for generating the required voltage. Option D, none of the above. Here option C is the correct answer. Number of conductors being less, they have to be necessarily long for generating the required voltage. Next question: cylindrical rotor armature cylindrical rotor alternators use dash ducts for efficient cooling. Options are only radial. Option B, only axial. Option C, both radial and axial. Option D, none. Here answer is in salient or cylindrical rotor, alternators use both radial and axial ducts for efficient cooling. So here option C is the correct one. Next question: alternator operates on the principle of options are electromagnetic induction, self induction, option C, mutual induction, and option D, self or mutual induction. Here answer is option A, electromagnetic induction. Alternator operates on the principle of electromagnetic induction, and auto transformer and potentiometer are work on the principle of self induction, and mutual induction principle is used in transformers. Next question: to obtain sinusoidal flux distribution, chamfering of poles is done in. Options are salient pole alternators only. Option B, smooth cylindrical pole alternators only. Option C, both of the above. Option D, none of these above. Here answer is to obtain sinusoidal flux distribution, chamfering of poles is done in salient pole alternators only. Salient pole alternators only. Option A is the correct one here. Next question: the salient pole rotors are not suitable for high-speed turbo generators due to. Options are excessive bearing friction. Option B, undesirable mechanical oscillations. Option C, high centrifugal force and windage loss. And option D, large eddy current losses. Here the answer is the salient pole rotors are used in hydroelectric power plant because it rotates at low speed. It can't carry high centrifugal forces and windage losses which are producing during at high speed turbo alternators. Here answer option C is the correct one, high centrifugal forces and windage losses.